Hello there. This is a fun type of problem. I think it's called the two poles problem, where you have these two poles on the left and the right, and the base of them is attached to the tip of the other for both of them, and you were trying to figure out this little height in the middle. Now I've drawn, I copied the image in advance because I know that there's going to be all kinds of triangles I'm looking at, so I actually wanted a separate copy of the picture. The real problem is just this one over here. So let's start by labeling some points. There's one triangle, ABC, and this one up here, that'll make another big triangle, call that D. They're going to intersect at, we'll call it E, and this point down here we can call F. And I'll copy that on the other side too. Now the frustrating part of this problem is I don't actually know how far apart the two poles are in the beginning. They could be 1 apart, they could be 100 apart, they could be like 17 pi apart. I really don't know. The interesting thing is it doesn't actually matter. That height will be the same regardless of how far apart they are. As long as this is, of course, on a line. If it's a curved surface, who knows? Okay, so let's start by setting up some similar triangles. So here I'm going to have triangle ABC, and that is similar to FEC by angle. They both have a 90-degree angle, and they're both using this little corner angle over here too. And I got the order right. I'm going up the short and across the hypotenuse, up the short, across the hypotenuse. And on the other side, I'm going to have triangle CDA, again going up the short across the hypotenuse, and that's similar to triangle FEA by angle. Okay, so now we can set up all of the proportions. Left-hand side and right-hand side. Now, one of the problems with the substitutions when I start doing these is I only know these 3 things here. There's a bunch of things that I don't know. So I need a placeholder, and I'm going to call the length AF, I'm going to call that the left on the bottom, and FC I'm going to call that the right. So over here I got the left, and I also have the right. Now there are also these diagonals involved, and I could come up with variables for them, but it turns out that they're not going to be needed for this proof, so I'm going to omit that part. But if you don't know where to go, you could certainly call that like X and Y and Z and W or something like that. Okay, so let's substitute in the things that we know. AB is 10. So I got these unknown ones in the middle, but over here, AC, that's going to be left plus right. Over FC, that's the right. And over here, I also have left plus right. So I'm going to ignore this one. That one has too many unknowns. And I'm going to do a trick here where I'm going to solve for what the left plus the right is, just by multiplying through by the denominator. So this is what I get on either side, and I can combine these two things. They both give me left plus right. So we can set these equal to each other. Now I can multiply through by h, that's going to cancel out. I can also divide by the 10, and eventually I get r equals 2l. And if you look at it, that r, it does look about twice as long as the l. So that gives us a relationship in there. Now what we can do is we can substitute this back into one of these equations. I'm going to move this up, scroll over a little bit to the right, and wherever I see r inside this equation here, I'm just going to do that one. I could have done the other one. I'm going to replace it with 2l. I get that, and that becomes 3l is 20l over h. I multiply the h to the top and divide by the 3l to rearrange, and sure enough, what happens is that those l's cancel, and I get that my height is 20/3, and that is already reduced for me. So this one, pretty daunting in the beginning, lots of similar triangles. You'll need additional variables in there, and you try to set up some kind of relationship with those variables. It's a nice little system. All right, thanks for watching. Character and Scholarship for Life.